Algebra I 10.2, Multiplying Rational Expressions. Rational numbers are fractions, aren't they? And when we multiply fractions, we multiply the numerators together, we multiply the denominators together, and we simplify the product to its lowest terms. So if we have 2/3 times 3/4, we multiply the numerators. 2 times 3 is 6, and the denominators, 3 times 4 is 12, and we simplify it to a half. Well, rational expressions are multiplied the same way. If we've got 5a to the third power over 4 times 2 over 5a, we multiply the numerators. 5a to the third power times 2 gives us 10a to the third power. 4 times 5a gives us a 20a. And this 10 over 20 becomes a half, doesn't it? And that gives us our friend the invisible 1 next to this a. So it's got an invisible 1 as a coefficient, doesn't it? We don't have to write that invisible 1, but that would be our half, okay? The only thing that's left with the a is, because this a has a little invisible first power, we do 3 minus 1. That gives us a squared over 2. So remember, the quotient rule says when we've got the same base number and it's written as a fraction, we subtract the exponent. So this becomes 5 minus 2. So it simplifies to x to the third power. Remember that? As long as this is not a 0, as long as the x or the b here is not a 0, we do subtraction. See? So remember that for the quotient rule. So all we did was 10 over 20 becomes the half, and this a third power over a is a to the 3 minus 1, which gives us our a squared, and it ends up becoming 1a3 minus 1, which is a squared, because we don't write that invisible 1, do we? We don't write that 1 coefficient, and it's over the 2. So when we simplify it, we get a squared over 2. See? So also remember that the product rule of exponents says that we add exponents when we multiply, okay? So remember that, too. We subtract when we're dividing, and we add the exponents when we're multiplying, all right? Well, with fractions, we can divide out, we can cancel out factors before multiplying. We have 2/3 times 3/4. This can cancel out as 1, 2, and there's 2 2's in here, so we have a 1 and a 2, and the 3 can cancel out as a 1, because there's a 3 here and 1 3 here, so that's a 1 and a 1. Now, when we multiply, we don't have to simplify so much. We just do 1 times 1 is 1, and 1 times 2 is 2, see? It's a lot different than doing 6 over 12, see, which is still a half, but by doing it this way, we don't have to simplify so much. We can also divide out factors of a rational expression before we multiply. If we've got 6 over x times x squared over 12, we draw one long fraction bar, and we put our 6 times x squared on the top as the numerator, and our x and our times our 12 as the denominator, and now we need to factor them with common factors. Well, the common factors for 6 and 12 are a 6 and a 2 times 6, right? So now, because x squared is x times x, we've got this all opened up in the numerator and all opened up in the denominator with common factors, and we can cancel out this 6, and we can cancel out these x's, can't we? And the only thing we're left with is x over 2. See how we did that? We factor the numerator and then the denominator, and we find and divide out any common factors. Take a look at this one. We've got x plus y over 2x times x squared over x plus y to the second power. Now remember, this having the exponent on the outside means we're going to open it up like this, okay? It means x plus y times x plus y. It does not mean x squared plus y squared, okay? It's on the outside of the parentheses, so it means we're going to open it up like this. It means we have 2 of these, okay? So we draw our long fraction bar, and we put our x plus y times x squared as the numerator, and we put our 2x times x plus y to the second power as our denominator. And now we factor it as x plus y times x, because that's what that means, right? And then our bottom one, remember, this is going to open up into 2 of them. So now we have 2x times x plus y times x plus y. Now, if you look at this part right here, we've got x plus y times x and x times x plus y. That's the same thing. The x is just in the front and the back, isn't it? That's going to equal a 1. So this entire thing got canceled out, see? The only thing that we're left with is x for the numerator and 2 times x plus y for the denominator. See that? All right, I've got 4 more examples, so bear with me. All right, we've got 4 over 5x squared times x minus 2 over 2x to the third power. So remember the product rule of exponents says we're going to add these. So when we multiply this one, we're going to get 4 times x minus 2, and we're going to get 5 times 2, which is 10, and the x squared and the x to the third power are going to become x to the fifth. See that? The only thing that can be canceled out or simplified is the 4 and the 10 as a 2 and a 5, see? Because they don't have anything in common. So that's simplified. We multiplied the numerators, multiplied the denominators, and we simplified. See that? All right, let's take a look at this one. This one has no common factors besides 1, so it's already simplified once we write it with a long fraction bar like this, see? It's a minus 2 times a plus 2 over 3 times a plus 3, see? We usually write the products of polynomials in factored form, so there's nothing to cancel out. We're done, all right? Now, if you don't remember how to factor binomials and trinomials, there's a link in this playlist that you can go back and review factoring, because if you don't remember from Chapter 5, when we did all this factoring, you need to go back and watch it, otherwise you're going to be lost, okay? You're going to be very confused. All right, so now we have this example. We have negative 2 over 2y plus 6 times 3 over y minus 5. We draw our long fraction bar, and we put our negative 2 times 3 on the top, and on the bottom we put these in parentheses times these in parentheses, see? We just copied it over and put them in parentheses. Now we can factor this denominator with the 2 in it. Nothing else can be factored. So this can become 2 times y plus 3, see? The 2y plus 6 becomes 2y plus 6, see? As the y plus 3. So now we've got this negative 2 up here, and this 2 here, and that makes a negative 1. We can cancel out this negative 2 over the 2. Now we've got a negative 1 that we're multiplying this by, so that makes that a negative 3. And we just copy these guys over, and it's simplified, okay? So just be careful that that's a negative 3 because that became a negative 1, see? All right? Now, you wouldn't want to do negative 2 times 3 and get a negative 6 because we're trying to open it up. We're trying to factor it, see? So you'd want to keep this open as factors, all right? All right, here's our last one, and it's kind of a long one. So if you don't remember factoring binomials and trinomials, this is why I was saying it's going to be hard, because we got a lot of them here, all right? So here was the problem. We had a binomial on top of a trinomial times a trinomial on top of a trinomial, and they all need to be factored. So we draw one long fraction bar, okay? And we write this in parentheses and put it here, and this in parentheses and put it here. We write this one in parentheses and this one in parentheses as the denominator, and now they need to be factored. This x squared plus 3x factors out as x times x plus 3. So we're going to put that right here, okay? So that's that binomial. And then the pink and the green one is this one. X squared minus 5x plus 4 factors as x minus 4 times x minus 1. So that goes here, all right? Now we need to factor this trinomial. And this one factors out as x minus 4, x plus 1. And this trinomial factors as x plus 3 times x minus 1. All right? So now that's our denominator. So here's the one trinomial, and here's the other trinomial. See that? So now you can see with my colors everything that can be canceled out, right? Look at this. This one can go. The pink one can go. The green one can go. And all we're left with is this x over x plus 1. See that? Very important you remember how to do your factoring, all right? So our next video, 10.3, we're going to talk about dividing rational expressions. If you want to go back and look in the other videos that we've just done, or Factoring Polynomials playlist to do a review, or if you want to get a review on canceling out to multiply fractions, or the previous videos we just did, look in the description of this video and there'll be all kinds of links, okay? You can look over the list of links and figure out which one you want to review, okay? Or which one might help you move on before we get deeper into this. I'll see you in 10.3. We'll talk about dividing rational expressions. I hope this was helpful, and I'll see you next video. Bye.